Okay, concept 1 is all about exponential growth and decay. So let's take some notes and try some problems to see how exponential growth and decay works. So we're going to start with growth. So exponential growth occurs when a quantity exponentially increases over time. So there's a formula for this, and it is this thing right here. It's f of t equals a times 1 plus r to the t power. So let's break this down and see, let's zoom in a little bit, what each of these letters means. Well, A is the initial amount, the amount you start with. R is the growth rate. And T is time, which makes sense. So let's solve some practice problems. The original value of an investment is $1,800. If the value has increased by 7% each year, write an exponential function to model the situation, then find the value of the investment after 15 years. So before we actually find the value after 15 years, we have to come up with a formula, and it's going to follow this model. So we're going to have some function of time, where A is our initial amount. Well, our original value was 1,800 times 1 plus our rate is 7%. We want this as a decimal. So what we're going to do is we're going to divide 7 by 100, and we're going to get 0.07. We're going to raise that to the t power. Okay? So our function is actually f of t equals 1,800 times, well, 1 plus 0.07 is just 1.07 to the power of t. Okay? To find the value of the investment after 15 years, we just take 15 and plug it in for t. So f of 15 equals 1,800 times 1.07 to the 15th power. Okay? You take that and you plug that into your calculator, and I'll show you how to do that. If you have a scientific calculator, it makes life a lot easier than a graphing calculator. Okay, so you're going to go 1,800 times 1.07 parentheses. This button right here tells me to raise it to the power of 15. And I get $4,966, and since it's money, we're going to round to 26 cents. So $4,966.26. And that's that one. Okay. Oops. Let's do another one. In 2002, there were 972 students enrolled at Oakview High School. Since then, the number of students has increased by 1.5%. Write an exponential function to model the situation, then find the number of students enrolled in 2014. So let's figure out our function first. F of t equals, our initial amount is 972. 1 plus, our rate is 1.5%. We're going to move that decimal place over two spots, so it becomes 0.015 to the power of t. So our function is 972 times 1.015 to the t power. Okay, they don't give us an exact year. We have to figure it out. So from 2002 to 2014, that's 12 years. So we're going to plug in 12. 972, 1.015 to the 12th power. We'll take our handy-dandy calculator. 972, 1.015 raised to the 12th. We get a decimal, but we cannot have decimal students. We can only have whole students, so we're going to round to the nearest whole number, which is 1162. 1,162 students. Please make sure when you answer these questions, you give me units, okay? All right, so that's exponential growth.